Google DeepMind just released a new study about what I don't get completely, but let's listen to it. So I'm using Google Illuminate, illuminate.google.com. This is a new, very good tool. It's similar to podcast generator, but it's even better in my opinion. So let's try this.
Ever wonder why some AI seems so smart in one situation, but then totally clueless in another?
It's a big puzzle, isn't it? We expect these models, to generalize, to apply what they've learned to new situations.
Exactly.
I'm just checking the audio volumes.
This paper dives into that, how AI learns from examples versus fine-tuning. It's pretty interesting.
Turns out there's a big difference. One method is way more flexible.
Intriguing. So which one wins? Let's start with the basics. What's the difference between in-context learning and fine-tuning?
In context learning is like showing the AI a few examples and letting it figure out the pattern. Fine-tuning is more like retraining the model on a whole new data set. It's a pretty big difference.
So in-context is quicker, but fine-tuning is more thorough?
Exactly. Fine-tuning can be powerful, but it can also lead to surprisingly narrow generalization. Yeah, it's weird.
The paper mentions something called the reversal curse. What's that about?
It's this weird phenomenon where a model trained on A is B fails to understand B is A. Seems simple, but it's a real problem.
So it can't reverse the relationship? That's a major limitation.
It is, but in context learning often handles reversals much better. Much, much better.
The researchers created some new data sets to test this, right?
Yes, they designed them to be clean tests of generalization.
So if from A follows B, the model AI doesn't know that from B follows A. But if you give few examples in the prompt, then it knows.
Avoiding overlap with what the models already know. It was a clever design.
Clever. So they could really isolate the learning process.
Precisely. They tested simple reversals, syllogisms, and even more complex logical inferences. A lot of testing.
And what did they find? Did in-context learning win across the board?
Mostly, yes. In context learning generally outperformed
Prompts.
fine-tuning, especially on those tricky reversals and syllogisms.
But I
Prompts.
bet there were some exceptions.
There were. When the information was part of a larger knowledge structure, fine-tuning showed some ability to generalize to reversals. It's complicated.
The paper also explores data augmentation. How does that work?
They used in-context learning to generate more training data, originally expanding the data set. It's a neat trick.
So they use the AI's own ability to learn to improve its learning? That's meta.
Exactly. And it worked. Augmented fine-tuning often closed the gap with in-context learning. Pretty impressive.
The paper also mentions sentence splitting. What's the deal with that?
They found that breaking down documents into individual sentences improved fine-tuning performance, especially with augmented data. Interesting finding.
Interesting. Why do you think that is?
It might be because it prevents the model from relying too much on correlations between sentences. That makes sense.
Did they test this on anything besides factual knowledge?
Yes, they also looked at process knowledge, like learning a mathematical procedure.
And did the same patterns hold?
Generally, yes. In context, learning still outperformed fine-tuning and augmentation helped. Consistent results.
How does this research fit into the broader field of AI?
It builds on a lot of existing work on in-context learning and data augmentation, but it provides some really controlled experiments to clarify the differences between these learning methods. A valuable contribution.
So it's a significant contribution to our understanding of how AI learns.
Absolutely.
Any limitations to the study?
They used some nonsense words and implausible operations, which might have affected the results. And they only tested one model family. Important caveats.
Good points. Future research could address those.
Definitely.
The paper touches on inductive biases. What are those?
Those are the assumptions a model makes about the world. In context, learning and fine-tuning seem to have different biases. It's a key difference.
So they learn in fundamentally different ways?
It seems that way.
The discussion also mentions learning by thinking. What's that about?
It's the idea that a system can improve its performance by internal computation, making information more accessible. A fascinating concept.
So it's not just about adding more data, but also about how the model processes that data.
Exactly. Data augmentation helps make implicit knowledge more explicit. It's all about making connections. Overall, this paper highlights the importance of understanding the different ways AI learns and how we can leverage those differences to build more powerful and flexible systems. A key takeaway.
That was a great discussion. Thanks for sharing your insights.
That was interesting. So in context learning is completely different from fine tuning, and they can be used for different things. Now, which things exactly? Maybe it is more described in the paper, but also I think we have a very shallow understanding of this. Thank you for watching, and you can check my other videos on my channel, and see you next time.